Jigsaw puzzle.
Yeah, jigsaw puzzles. Yeah, like 1,000 pieces, and that sort of, at least to me, reminds me of how it is when I'm sitting with models, especially old models that has been nudged in the corners and not perfectly aligned anymore, and I need to fix them up and move things around, and it's almost like doing a puzzle. It never ends, it feels like. So everyone sees my screen now? Yeah. Good. So suppose that you have an existing model and you need to move things around, and it get messed up with the lines. Oops, that was not supposed to happen. Like if we have lines like this, and I need to move things around, then what we have changed during this Christmas holidays, instead of doing puzzles, we have been doing development in a puzzle-like way. Because what should happen when we move this around is that it recalculates and puts it in a nicer way. So it switches the sides, and this have sort of been done before, but what is totally changed are the algorithms for what happens when you have many associations like this. Let's see that one. So what should happen now, and what should happen now, and what should happen now? So basically what we do is that we divide a side like this on a class into 3 sections. One section is 25% in from the top, and one section is 25% in from the bottom, and then there's the third section that's 50% of the total width or height in the middle. And if classes align like these so that they show their faces to each other, the 50% face, then we will try to make them straight. But as soon as that's not possible anymore, we do them in the best angle that we find, and we spread things out along this available side. So depending on what you move, it will clean up like this real quick, we hope. And that's really much better than it was before. And of course, the real issue comes when you, let's see, if I copy a class and just paste it in, I get a new, all right, let's do it like this instead. Delete that, and I'll drag it in from here. Now it's the same class once more, but there's a lot of more lines. So what should happen when we move this one? It cleans up and sorts them to have all these that goes in an angle above 0 in the first section, and the angle below 0 in the second section. So we don't get that much colliding lines. So what should happen now when we have a lot of colliding lines? Well, now we do this separation of the 25% from the top. We use those for this one with the angle above 0. And we use the 50% space in the middle to draw the straight lines. And this one for the rest of the 25%. So this is just pure hard math to find out the center of gravity of, or the center of a class or a box, and that's what we aim for first, and then we find out where it collides with the side of the box, and then we find out if there's anyone else wanting to reach this side, and if there is, we need to look at the whole bunch of lines and do a better distribution of the positions that we should use. So let's see if we mess things up with even more lines. Of course, things still can get messy, and there's no immunity from that, but at least now my general feeling is that it behaves a lot smoother and with less issues than we have done before. So can I get a cheer for that one?
Yay.
Toggle the lines square.
Yeah. So if we turn on the squared lines, what they aim for this, I haven't really done any changes to the squared lines, but this is just a part of the things that I'm going to show you now, and the ambition is that we should be able to spend less time manually fixing up diagrams and trusting the logic more. I'm not sure that we're fully there yet, but that's the ambition. So the square lines pretty much work as they have done before, and then we aim for the next via point, so to speak. So if I turn on one of the lines, that it should be squared. Square line, and move that. We still aim for the last via point, but moving it back and forth, we can trick it into doing, because we don't do any analysis for the whole way, and if we want to clean this up, we can do like that. So,
but it looked a bit better than before, because when you move a class, this toggled square lines just wonks it up totally. No, this looks better. Great.
So what I've also been doing instead of the jigsaw puzzles is to think about how to lay out diagrams. And having watched a lot of YouTube lately for AI algorithms, etc., they always work with a sort of a loss function, which basically is the level of pain. How much wrong are we? And that's really something that we need to apply to auto-placing diagrams as well. We need to know what the goal is. What is a good diagram? In order to create an algorithm that can help us nudging the model towards that goal to become good. So, of course, we can see that.
Hans?
Yes?
Is there I've always wondered this. Do you have a preferred color coding for the classes for different reasons? In ECO, I've always used yellow to denote persisted classes, and I use like a blue to denote transient classes. But in the new tool, the classes all start in red, but
yeah, so
I don't know if there's a standard for coloring or not.
No, there's we don't have a standard as such, but of course it's very practical to give a color to a specific category of classes, and what those categories are for at least for me, it's almost always something in the domain. So these are for sales, and these are for purchasing, and these are for HR, etc. So I get whenever information connects to each other, I get a really colorful diagram showing me that there's information from a lot of places. But that's just me. When it comes to there's a lot of ways to signal things, and we should look into that in a future session. But you could put like
I'm
icons,
thinking,
etc.
are they available on the wiki? I have a set that I always use. For example, that I have a little database icon with a stop sign on top of it that says like it's not persisted.
Yeah.
And little warning signs for deprecated attributes and things like that. I wonder what are they called?
So they're under here, I think, under tag extensions. So there's a thing called ensure default, and there's some default trigger things, and this is just a SAML, so you could easily create a new one and put in new images here. And if you have images there, then we could put on like, how the hell is that done?
Yeah, there it is.
Yeah, but so then we would to do a new extension and give it an. I'm not sure how we connect it to the is persist. Yeah, we do it like this, right? So we're gonna give it my extensions, just a name of my own calling, and I'm gonna add a tag type to that. And what is it that I want to associate this tag type to? A class. Okay, and I'm gonna call this one is it persistent? And the default value, and let's see, transient class, that's the symbol, so I'm going to add that symbol. So if this is false, I'm going to use that symbol, and if it's true, I'm not gonna have a symbol. And having done that, if I select the class, it shows up here as my extensions, since I call it my extensions, and is it persistent, since I gave it that name, and it has two values, true or false, since I gave it two values. And when I say false, this one should get a symbol here, because that was what I said, and maybe that's because so we got sidetracked, but that's okay. So the transient class, true, false, and just to test, I'm gonna give this another value, true, false.
Exactly. How is this?
Save. There's demo 1, 2, 3. Let's call it that. I'm gonna close this and reopen it to see if that's the thing.
I've done it before by having an attribute tag extension on the tag name persistence.
So
and it's
now it shows up. So it was a thing with a it doesn't reload them. It checks this on file load, I think. So if I select the class and I turn this into true again, then it changes to the other one. So that's one way to dress up your model with more information, and you can put these icons on attributes and on association ends. So there's a lot of ways to get information, meta information, extra meta information onto your model. But that was not what we were supposed to talk about today, at least not to my plan. We were talking about auto placement of diagrams and the loss function, and what is a good diagram. So I implemented a thing here that sort of draws the loss function, what it feels like is good and bad with just this diagram. So all the blue boxes here are just a representation of these. I think nothing of the coloring or things like that, just the red ones, because this one is pretty much red because it crosses one box and it goes over another line. So what the algorithm does, it disregards how many associations or lines there is between things. It just finds out that there's at least one line between things, so it reduces the complexity what it needs to calculate. And then it does a lot of math to find out collisions. So if I were to move this one over here and this one over there and push the pain level again, it sort of comes up like this. So now it's all green. But if I were to do something crappy, it will be like this. So that's the first step in doing some kind of auto layout, because now we can have a clear definition of what is good and what is bad. So as long as we have a good definition of what is good and bad, we can do some iterations to see if we move things around, does it get better or worse? And of course, the solution space is humongous, so it will, if we're not smart about this and just try every possible pixel position, it would take forever. So we need to be sort of smart, and one way to reduce the solution space is to treat each class as just an item in space, and have a uniform space instead of having all these pixels with different sizes. And if we do that and let it iterate over that, that's much faster. So this is the algorithm that we have implemented that we call natural line cross, and it optimizes to reduce the crossing lines. So what it did now, it couldn't find a solution for that one initially. It will try a couple of times. So, and I put a quick key here, Control K, to really make it easy to find a good solution for this. Of course, now it's kind of now all the classes were equal in size, so it wasn't a big issue. But if they are not equal in size, there's a whole skew of new problems with things colliding when going from this idealized space where we treat everything the same size as and trying to apply that to a more practical world where they are not the same size. So let's make this one really much bigger then. And okay, and trying to, so now it zooms out in order to get things to get a good solution. And since things really can zoom out to find the best practical solution, we also added the shrink mechanism that after the placing can put some work into trying to reduce the diagram. So let's run that one and put a Control J on that, so we can have it to sort of quickly try something out and then quickly see how that looks. So if we were to try this on some real models, which I've lost, I'm gonna find them. I had some good examples. Let's see, where's that? So yeah, here, Damien, you can see how what I meant by coloring. So in this case, these purple things are for the marketing department, information from the marketing department, and the blue things are from R&D, and these are from sales. Of course, this diagram looks crappy because it's been around, and what happens typically is that the classes are changed in another diagram or for other reasons, and this diagram sort of grows. So now they overlap here. Of course, we have had since before the expand to avoid collision, which is somewhat helpful to reduce those kind of problems. But what we want to do is it's easy to get caught up in fixing these lines. Now I'm can spend like a good part of an hour trying to get this to look okay again. And of course that's not optimal. So let's just press Ctrl K instead to see what it does. So it found this solution that's really roomy, and that's not good for me, but I'm going to press it again to see if, given the new situation, if it can find anything better. And if I'm happy with something like that, I can press the Ctrl J to reduce it. So as for each iteration of the Ctrl J, I can see how things move a bit. And getting closer together. And of course, if there's something that I want to help it with this, I got stuck in the corner, it can't pass these, so maybe that's better over there. So let's try out a few of these diagrams that has been let's try some of the smaller ones. This one. So it got exploded because they were very different sizes. And see. Now I shrink it together. And the notes and place diagrams and things are ignored. They are not considered. But this is like auto-placed completely from this algorithm. And this is really much better than we have ever been able to do it before. And almost as good as if someone had spent some time on it. Let's look at this one. Control K, exploded, and I'm gonna do another Control K to see if it does anything else. That's okay, and I'm gonna try to shrink it. I can hear my CPU rushing a bit. There's a limitation on 4 seconds iteration lapse too, so it won't get stuck longer than 4 seconds. So it can be dependent on how strong machine you have as well to get this, how far it will get in the iterations. But this is pretty good. It's a bit more spacey than the original manual one, but there's really few crossings. And along with the other changes we talked about in the beginning, it behaves really well when we move things around and adapts to the environment. And of course, the overall goal with this is to reduce, or rather increase, the speed with which you model, and you can move on to more important and more valuable things than doing this puzzle game. This one looks crap. Control K, Control Y. So it's pretty fast, rather okay. And then, not to get stuck in this, but there's another interesting aspect of this that I wanted to show you, because that's the cool thing about this kind of algorithms that, or I wouldn't say that it's artificial intelligence. They are iterative, and they are working against the loss function, and what emerges is something that almost looks like intelligence, so to speak. It looks like someone understood what it was that happened. So if we were to have sections of the model that aren't really connected, they're just drawn on the same diagram, but they are not actually part of the network. Those should be kept on the side, so to speak. Let's see if I can find that model. Need to think where it is. I'm thinking of the it must be here. Crappy that I lost it. I'm thinking about the Sci-Free model, Lars, that was sort of had a few interesting features that turned out pretty cool.
Can't really give you any tips, but you can't just sever one of the models you had,
Yeah.
like cut off a piece.
Cut off a piece. So now this sort of floats in the middle here all alone. And that's discovered. All right. And if I shrink that down then, oh, I got another piece as well, but that one collides with, let's see. Okay, so let's give it one more shot to but it found one of the pieces. Okay, we have one section here and not really sure why this is having a hard time to adapt. There's another one algorithm that sort of smashes out every class in a grid. That is not a good starting point, but a starting point anyway for it to work. So it's kind of sorts everything anew. So this one's got stuck over here. They should be here. So it's not perfect, but it's an interesting approach to automate things, because when I first started to think about how to auto-place things and how to decide what to move and where, it's like very easy to overthink it. And what a human does, when, at least I think, when trying to make this look nice, we immediately use our eyes and visual cortex to decide that it won't go there, 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 it won't go there. Here it's okay. And we don't think that we do that, but surely that's what we do. And then once we accept that that is what we do, we could have the computer do that for us. So that's really what the algorithm does. It sort of does this idealized space and tries to fit the class, each class, next to the one it's connected to, and then it checks the loss function. Is that better or worse than it was before? Well, it's worse. Okay, then we move it back. And if there's no room, because there's all the positions around this are filled, then we just expand the whole grid to make room. And then we check the loss function. Is that better or worse? So just plain raw calculation, and I think that's how one does it in the head as well when it comes to this kind of layout, manual layout, and also when it comes to jigsaw puzzles. Just brute force.
A question asked, we have this setting of the size of the class. Have you played with the weighting something, or I don't know how that even would work or do, but
so if each placed class can have a size on the diagram to make it more important or more
and then I guess that would be like a center point for the algorithm somehow.
Actually, it won't look in on that. I've done a lot of experimenting with the different approaches, but the best approach is to just go with this pane-oriented. The best approach that I've found so far is to go with the pane-oriented approach to see what's the status right now, what is good and what is bad, and try to improve that. Of course, there's a lot of possible ways to solve the same problem, but this is what has to
I'm thinking, if you could, I guess then it's about introducing other panes or gains.
Yeah.
I mean, so, the big ones kind of tend to be in the middle. I don't know, of other things, or that,
But also the ones with the most connections tend to be in the middle, because that's where they end up when we do it like this. So
Hans, I have a comment that relates more to the first thing you talked about, the auto distribution of connecting lines.
yes.
And it's kind of a converse thing. If there's an option to turn that off, because sometimes, and maybe I won't be so frustrated with this now, but sometimes I've got all my connections where I want them, and to avoid label collisions and things like that.
Yeah.
And then, but I just want to move a class around, just a slightly different position. And when I move it, it auto distributes and I've lost that. Is there a way, or could there be a way to prevent the auto distribution?
Yes. So when you select the diagram, you have this setting, correct lines on move. If we turn that off, it sort of stops the calculation. It will still try to not go through the class, but find the other side if the line is on the other side. But it won't do that much thinking about in what angle things should be.
Okay, that I wasn't aware of that. That's great, thanks.
So let's turn that on again, and then then it cleaned it up. So it's a good question.
And when it comes to chaos, you have made quite an improvement on state diagrams also, because they were really tricky. If you moved something and it's like boom, all broke.
Yeah, so one of the major issues with the state diagrams was the things like this, when it's inner states. That this one has squared lines, and that might not be okay still. I'm gonna toggle. Yeah, this might still be a bit crazy, but before it had an error on the calculation. This point was thought to be up here, so everything got really messed up. And these square lines I see are not correct as of yet, but if we toggle the square lines, which seems like a tough thing to do, and yeah, this is crappy. Let's toggle that one as well.
But I kind of, it felt better when I tried.
Yeah, you see, once it forgets about this, all the via points, it's better, but there's something with the via points that's messy. So now it's much better once we get away from those. If I want to hide this pane drawing in the background, I can just switch back and forth to the diagrams, and that will go away. There's something with this one should of course be there, and let's see if it was there. Not sure why that goes wrong. It's something with that calculation. Oops. Yeah. So not all there, but closer to where at least my ambition was to end up. Because as if we work on a model for like 10 years, there's a lot of diagrams in the end. And then of course you need to go back and show a diagram to someone, and it all of a sudden looks like super crap, and what are you going to do?
One thing I do quite often, if they have gone like crazy because you've added attributes to classes, is that I click on the new ones that might not be relevant for that diagram, and then I use the delete key without the control delete. And when you press the delete key, you don't delete the attribute in the class, you just delete it from being displayed. But that also switches the view mode of the class to not accept new things coming from like added to the model. So then your diagrams will stay more stable. And you can also choose this on the class if you show that, Hans, if you right click and then you show
let's see.
The class, right?
If I'm on the class and introduce and remove. No, that's for associations. That's
it's a picked what? Features
over here. Yeah. So pick, show, and features. So these are the features that are available, and this is set to show all. But of course we could move one of them to be among the picked, but we also need to say that we show only the picked ones. And we only show the picked, we only show that. But what Lars is saying is that we can do it like this. Just not control clicking, just clicking delete button.
I think you can right click also.
Yeah. And
delete.
That's the quick key for turning that thing on.
Remove from diagram.
So now it has been I deleted one, so that's there, and all the rest are in the picked. And how come this is show all?
Yeah, it's always been that way, but it works anyway. So
okay, that's wrong.
I haven't understood it, but it works.
And if I add things while I'm here, they are added to actually show as well. But if I were to add things somewhere else, like here, yeah, that might. So the attribute 5 added here, attribute 6. But since this is in the new mode, it won't destroy this diagram and it won't grow here. No.
I usually use that to get better control and the diagram's not growing uncontrollably and like breaking.
To make them more stable over time.
Yes, and more, and then otherwise they also tend to grow with things that doesn't relate to this diagram. But of course, it's always a trade-off. Everything is trade-off.
So this turned out nice on the autoplace. I think this has been autoplaced before. So here I would probably go with the expand to avoid collisions. But I could still get stuck here at least for 20 minutes trying to fix things up. Maybe just autoplace everything. Shrinking it back. So I can hear my CPU doing a lot of work. Yeah, sort of like that. And the algorithm doesn't start from scratch. It looks at what's on the screen right now. So it will be a different result if we manually move something and then say that this is the new starting point. So that's good to know that you could influence it manually and it will take that into account to reduce the complexity. So hopefully it could be a good companion in certain situations to clean up diagrams faster and leave more time for modeling. Comments, questions?
I don't know. I mean, if there's no immediate questions, do everyone know that you can drop diagrams on diagrams and that you can put state diagrams on other diagrams, for example? Very nice thing. Been there forever, but I mean, you don't know it.
Oh, it turned out small.
And also drop view models, so to quick access.
Yeah, so that's a good way to make like entry diagrams. So because if you have put them on here, you can just double click and get to it, and then you can sort of navigate around by just following the diagrams. So that's a very good way to get a bit more speed in finding things. I'm also thinking about picking up the process work again. That has been a bit of a forgotten thing. But it's really good to associate at least view models to certain process steps, because that's work that's gonna be done in the organization. And if you just can associate all the view models that are needed for doing that work, it's much easier for anyone to find what are the different tools needed to do this work. Because if you work over long periods of time, you forget things you did a year ago. And when someone comes to and asks you, how are you supposed to act when we need to create a new campaign? Right, let's see. And then you're back to zero. But if you have the process tree, you could just say, okay, campaigns. So you're like sales, right? And you're what role are you? You're this role. Okay, you have these tools. You have these screens. One of these. Let's see. One of the work items is creating a campaign. Oh, that must be it.
Are you showing something now, Hans?
No, I'm just talking. And
Okay.
it's these process steps that are defined up in this enterprise architect information. So we haven't done much in this model, but as soon as I'm starting to use it and adding a process tree of the details within, I really quickly learn to appreciate the effect of being able to cross-reference the names of work items with the tools like view models. So we're going to pick that up going forward, I think, this year. So it's been a crappy 2020 and it's going to be a great 2021, right?
Yes.
Yes.
It's the year of MDriven, I think. Could be. Yeah, so we're sort of short of time, and I want to thank you all for attending and hope to see you in 2 weeks.
And please send along any questions.
Yeah.
Good.
And ideas on what you want to see, and if there's things that you're stuck on or thinking about.
And you can always see all these videos. I think they're on YouTube, right, Hans?
Yes.
Our channel. So you can spend all your lunches in between our bi-weekly thing with watching these as a reruns.
So I'm updating this article on the blog, Wednesdays-with-MDriven, and put the links to the videos that what we have discussed on earlier occasions.
And then, of course, you can speed them up and you can jump also. So that's the good thing with not being in reality. You can always skip ahead.
Yeah. Good. See you next time.
Thank you very much.
Thanks.
Thank you.
Thank you.
Have a nice
Bye.
Bye.
Thank you, Hans. See you in a couple weeks.
Yeah, great. Thanks.
Jag tänkte bara fråga dig om